In this video, we'll discuss how to find the present value for a compound interest problem. First, remember the compound interest formula, which says that the future value is equal to the present value times 1 plus the interest rate per period, I, raised to the total number of compounding periods, which is n. Now that's again the same thing as the present value times 1 plus the annual interest rate divided by m, where m is the number of compounding periods in 1 year, raised to the m times t, where t is the total number of years. Now if we take that first part of the formula and divide both sides by the 1 plus I raised to the n, you get that the present value of $8 compounded at an interest rate of I per period for n periods is equal to P equals to A over 1 plus I raised to the n, and that's the same thing as A times the quantity 1 plus I raised to the negative n. Now another way to view this is if looking at the formula with the R and M, we get that the present value is equal to A divided by 1 plus R over M raised to the MT, which again would be the same thing as A times 1 plus R over M raised to the negative MT. Now it just depends if you're more comfortable using which formula. Both of the formulas do represent the same thing because I is equal to R over M and N is equal to M times T. So they are the same formulas. Now for this example, let's say if you're to find the present value of the future amount 8,500 at 6% compounded quarterly for 8 years. So we get the future value is equal to 8,500, our R is equal to 0.06, M is equal to 4 because it's compounded quarterly, and T is equal to 8. So plugging those into the formula, we get the present value is equal to 8,500 divided by 1 plus, well, now the interest per period will be the 0.06 divided by 4, and the total number of compounding periods will be 4 times 8 because it's compounded for 8 years, 4 times a year, so that would be 32 times total. Now plugging this into our calculator, we get that this will be approximately 5,278.4398. Now we'd probably round to the nearest cents since we're talking about money. So the present value is $5,278.44. Now a similar example would be, what price should you be willing to pay for a zero coupon 5-year $5,000 bond at an interest rate of 3.5% compounded semi-annually? So this question is asking, okay, how much do you pay so that in 5 years you're going to get $5,000 from this bond? So A is 5,000, R would be 0.035, M would be 2 because it's compounded semi-annually, which means twice a year, and T is equal to 5. So plugging this into the formula, with the price we should be willing to pay is 5,000 divided by 1 plus 0.035 over 2 raised to the 2 times 5. Now if you plug that into your calculator, you get approximately $4,203.64299. Now rounding this to the nearest cent, the price you should be willing to pay is $4,203.64.